Thank you again for everyone joining us today for our GoAERO expert lecture with Parimal Kopardekar from NASA. PK serves as the Advanced Air Mobility Mission Integration Manager, and we're so pleased to have him here for our lecture today. As you know, we're so pleased to have our partners Boeing, NASA, RTX, Honeywell, Iridium, Global Aerospace, and SAFT joining us with GoAERO, along with 25 or more organizational partners from around the world who are supporting GoAERO. PK will be speaking about advanced air mobility within NASA's research and development focus. He coordinates the advanced air mobility mission integration within the ARMD, Aeronautics Research Mission Directorate, enabling progress of the AAM system. In addition to his strategic role, PK serves as the director of NASA Aeronautics Research Institute and a senior leader and advisor for ARMD. In this capacity, he is responsible for exploring new trends, research areas, collaborations, and partnerships relevant to aeronautics enterprise. His focus is on unmanned aircraft systems, advanced air mobility, wildland fire management, autonomy, and future airspace operations. Recently, he co-led a comprehensive needs assessment study for wildfire mitigations. In the past, he served as NASA's senior technologist for air transportation systems. He invented the unmanned aircraft systems traffic management to safely enable large-scale drone operations at low altitudes, which is now being globally adopted. He also chairs International Civil Aviation Organization's Unmanned Aircraft System Advisory Group. He holds a Doctor of Philosophy from the University of Cincinnati and a Master of Science from the University of Buffalo in Industrial Engineering and a Bachelor of Engineering degree from the University of Bombay in Production Engineering. PK, thank you so much for joining us. We're so happy to have you here with us today.
Thank you for inviting me. So I'm really excited to be here. Let's see. I'll share my slide. All right. Can you see my slides?
Perfect. Thank you.
Okay. Thanks a lot, Nidhi and GoAERO. I'm really excited to be here. And I would love to talk to you all today about NASA's advanced air mobility research and development activities that we have been doing. So you will get a perspective on all things that we're working on. So if you look at our NASA's aeronautics portfolio, there are four major transformations we are working on: ultra-efficient airlines, high-speed commercial flight, which is supersonic, future airspace and safety, what kind of airspace system we will look at, and then advanced air mobility. So today's topic is focused on that advanced air mobility quadrant. So here are many use cases related to advanced air mobility, from emergency response, which is one of the core themes of the GoAERO Prize this year, cargo delivery, vertiport, automation, landing, and airspace management, infrastructure, many things that touch this advanced air mobility. And we are working on all of them, and we'll talk some of these aspects in a selective manner. But fundamentally, why I'm so excited about advanced air mobility is that if we're successful at advanced air mobility, it could completely transform the society as we know today. If you think about 1 mile of road, only takes you 1 mile. And if you take 1 mile of aviation land, that can take you many miles in different directions. You no longer will have to be confined by living and workplaces which are close to where the roads take you. So you don't have to have a central business districts. You don't have to live by major highways or access to roads, because now you can actually spread out and have much more integrated greener spaces as well as living spaces and businesses. So that changes the way the society could totally look at in the future. And this, while this might take a long time, but it has a real promise of transforming the society at large, which is really exciting. And my personal dream, obviously, is to get every zip code in the world some kind of access by aviation. So it could be drones, it could be urban air mobility, advanced air mobility type of aircraft, and in some cases where you have access to airports, of course, supersonic and such. But really, once you touch every zip code by aviation, it changes the way we live and function and efficiency and productivity can significantly grow. So I'm really excited about the future and the long-term prospect of advanced air mobility and how that could transform the society at large. There are many use cases, as you saw in that little animation, but here are the, sort of what we call OV1 that shows operational view one for those who don't know what OV stands for. Regional network is cargo delivery, intercity, airport transfers, the on-demand air taxi, medical supply, all kinds of things. So the goal is to really build safe, sustainable, affordable, and accessible aviation so that we can transform our local and regional aspects. So this is the same chart, kind of gives a different flavor. Here are 5 different operations that touch the advanced air mobility. Small drones and drone traffic management or unmanned aircraft system traffic management. Currently, those operations are being tested at the key site in Dallas. So we're really excited to be part of that, working with many collaborators as well as the Federal Aviation Administration. Then second is the piloted electric vertical takeoff and landing. Initially, it will be under VMC conditions, visual meteorological conditions, and later on it will transition to instrument meteorological conditions. So Joby and Archer as examples of that. Then you also have electric, basically conventional as well as short takeoff and landing aircraft. Initially, they will also be piloted and later on autonomous. Electro-aero beta are examples. Autonomous STOL and CTOL, which is reliable robotics and Merlin Labs and X-Wing now it's into Joby. These could be electric, it could or conventional, and then the last one is autonomous eVTOL, Whisk and LRIR type. So different use cases have unique features and basically their needs in terms of their aircraft, the capabilities of the aircraft, the systems that they will support are needed to support them, and where they would operate. Here is another view of what we look at from advanced air mobility architecture in terms of various aspects of entire architecture: airspace management, vertiport management, aircraft technologies, how the fleet management will work, aviation safety and security aspects, in-time safety management, and infrastructure as communication, navigation, surveillance, weather, and so. So let me talk about the 3 main things that NASA is focused on, which is airspace, aircraft, and community integration aspect. So this is where our primary research is, and I'll talk one at a time. So let's start with the airspace. When we when we talk about our NASA's research, it's actually broken into many projects. So I'm focused on the mission, which is integration of the projects, products. And the reason I give you this list of projects is that we use a lot of acronyms, and you may want to take a screenshot of this because that will allow you to keep up with some of the acronyms. But at one, these are the number of projects that we have. And if you are more interested in any one of these projects, you can actually go to the website and find out more information. What is safety a project is doing, what the flight demonstration project is doing, what tools and technologies project is doing, convergent aeronautics, and so on and so forth. So, but primarily, you will see action in terms of simulations or development or flight testing through advanced air mobility pathfinders on this particular aspect. So let me talk about airspace first. So if you look at the FAA's urban air mobility concept of operation, they break it down into 3 stages. One is initial stage, midterm, and mature stage. NASA's research is primarily focused on midterm and mature stage. Initial stage is basically just entry into the service, and they will be very low density. But in the long term, where we would like to see this advanced air mobility flourish into very high scale, safe operations, and that's what our research is focused on. So that touches the air traffic management. It touches the types of services these vehicles are needed. How do they cooperate in very um, core airspace, which is some people call corridors, some people different names are used, but basically, how do we have a system that will allow them to scale these operations in a safe manner? The way we collaborate with FAA is also important. We have something called research transition team. So our project products are documented and then collaborated through this research transition team kind of a construct that allows us to transfer technologies and concepts and the learnings we have to FAA, and FAA in turn provide subject matter expertise to make sure that our research is relevant. So what we are focused on in Advanced Air Mobility Pathfinder Project AMP is this cooperative operating practices. What happens when you have a number of these vehicles want to operate at the same time, same airspace? How do they collaborate with each other in terms of that airspace? So how do they do strategic planning? How do they deconflict themselves in these cooperative areas? So that's part of our technology capability level one. After that, we get to the tactical deconfliction, which is TCL, which is technical capability level two, and then resilient operation, which is how do we manage disruptions that could be because of things like weather, GPS failure, and so on and so forth. So one of the important aspects is to building an architecture that covers the number of aspects related to these functions that are needed. So, for example, demand capacity balancing. You don't want to get to a place where you just cram a whole bunch of aircraft where you cannot safely maintain them. So first thing is to figure out demand that's needed, that's going to happen in the capacity of that airspace or that particular vertiport. Then you figure out how to schedule and sequence them. Then you figure out how to collaborate with each other in terms of if there is any conflict, strategic deconfliction and such. So this architecture allows actually us to use third-party service suppliers, building on what we already learned from UTM, which is unmanned aircraft system traffic management and architecture that we developed for that, and that's getting adopted as I mentioned in Dallas now. And so similar things are happening here. We basically allow third-party service suppliers, which are called provider of services for UAM, to offer certain services such as flight planning, tracking, communication, deconfliction, and such. So fundamentally, our end product will basically get to a point where this architecture, the functions that are needed to safely manage these operations and the performance requirement for those functions will be identified through the research and development and flight testing and simulations. Another aspect of our work is basically making sure that we can do this integrated concept of use. So not only you have these vehicles, but then closer to the airport, they will also operate along with the aircraft, regular operations. So what kind of rules are needed to operate them in a safe manner and coexist with the other traffic that goes on? What happens when there is a bird strike as a contingency? What happens if there is any other failure? So those are very important aspects to study and set requirements for. This is one example that we learned a lot from US traffic management or UTM for beyond visual line of sight. We know we had followed similar aspects here. That work started in 2013, and we had 4 technology capability levels, TCLs. We tested them with complex environments all the way up to a urban airspace like Reno and Corpus Christi, and then it ended up being operationalized, initial implementation in Dallas airspace. So similarly, we built architecture, we tested the requirements, functions, and this idea of US or unmanned aircraft system service supplier was born in that aspect, so that the third-party services provide these support for the operations, and these service suppliers interact with each other through prescribed protocols. There's another project that's focused on wildland fire. Nidhi mentioned in the beginning that we are working on wildfire fighting kind of research. So the idea here is, and this is one of the important use cases for the work that you all are doing. What happens today is that there is an air boss or who is sitting in the aircraft and watching outside the window. The aerial basically suppression aircraft, the fixed wing and the rotary wing aircraft that are dispatching water and retardant are flying under that particular aircraft, and the air boss is watching and giving directions to those aircraft that are doing the suppression effort. Now, as a result, this is very manual and very intensive workload, and it's all eyeball traffic, basically based traffic management, so to speak. Visual observations as to where the aircraft are. So when the smokestacks show up or the visibility goes down, the air boss cannot see these aircraft, and then they stop the operations. As a result, out of 24 hours, they operate about 6 to 8 hours a day from the perspective of aerial monitoring and suppression. And the goal here is to basically say, can we use drones and autonomous systems that will continue to fight fires and suppress them, and use the what we call as drone in a UTM in a box, or portable airspace operations, or portable airspace management system in a box, that allows you to for air boss to manage the airspace from outside the aircraft. So the air boss would be sitting on the ground, and you can basically plan their trajectories, and the drones will operate and then continue to fight fires 24 hours a day. So ability to operate during degraded visual environment is very critical for this kind of operation. So this is one of the exciting things that we are working on. And when we realize the bottleneck there is really airspace management, ability to manage airspace from outside the aircraft, it was very obvious for us to this is an area where we can actually make a big difference. For system-wide safety, their goal is to focus on in-time management. So not just after the fact, but during operations, what's going on in terms of what the environment looks like. Is there any interference? Is there any degradation? Are there any challenges due to weather? And all of those are coupled, and figuring out is the safety maintained for that particular airspace as well as the aircraft. So let me transition to aircraft-focused research. So we have a number of working groups. You can join them. And there's one that's focused on M2N, which is multi-vehicle working group, where we focus on human automation teaming and ability to manage number of aircraft by fewer people or fewer managers. And then their key research there is obviously is how do we manage contingencies when you don't have one-to-one relationship between aircraft and a pilot. Then another one is this basically video environment that we have built, and you can download that. Initial data set is available for you all to look at the algorithms and such. Next one is the aircraft safety and noise. It's really important that the noise footprint is very well understood so that there is community acceptance of these aircraft, and obviously safety is paramount. So drop test, passenger ride quality, handling quality of the aircraft itself, and understanding of the noise and annoyance and things like that are studied in this particular activity, including the propulsion aspect. So there's a lot of body of works and design tools that NASA has built over a period of time, last 30 years, that are available through this project as well. We are also looking at building an open aircraft, sort of a reference aircraft that will allow us to do some kind of interchangeability and collect data that can be shared with wider research institutions as well as universities and industry at large. So that's part of the reference aircraft work. And then we're working on basically a subscale model that will allow us to test these ideas in terms of autonomy and different types of configurations and such. Let me talk a little bit about the community integration effort that we're working on. So we have something called a community integration playbook that we built. So this playbook document actually describes all the interesting aspects that communities must take into account, such as weather, the location of the authority port, and integration with other traffic and such, as they decide how to actually include the advanced air mobility into their communities. And we have another report that's focused on advanced air mobility missions for public good that has number of use cases. These are actually a very good number of use cases that you can study about and focus on that. A couple of videos that are available there as well. This is another interesting activity that we're working on. It's called airports as energy nodes. So the idea is to basically use the land that's available at the airports and put solar arrays and basically generate energy so that we can use that energy to support the charging infrastructure and others. So we have something called Advanced Air Mobility Ecosystem Working Groups. For those who are interested in joining NASA's working groups, please join at that link. We have somewhat routinely working group meetings that kind of consider industries issues or research needs and collaborations, and then we share our NASA research and our products that are coming about on these working groups, and there's this good bit of interaction that occurs in this. So we talk about visions and ideas related to the vision, the research plans and the transition paths we have, any different strategies for engaging with public, and then identification of necessary, basically research priorities, architecture requirements, any support standard bodies that we provide. So all of that is discussed here. So it's a very valuable resource for all of you. Our research is conducted at four different centers. So NASA Ames, which is in Silicon Valley. The second one is in Armstrong Flight Research Center, Glenn, which is in Cleveland, Ohio, and then Langley, which was our first center, NASA center, which is in Hampton, Virginia. So if you get an opportunity to visit them, obviously, please do that. You can also go to their websites and see many of the facilities as well as types of research we do. We also have a very good internship program. For those who are interested in NASA internship, there is a website called intern.nasa.gov. I would highly recommend you go there and apply. I think the deadline for this year's summer internship is coming up pretty soon. So I'd love to see you all apply to that for those who are interested in that. Again, if you want to learn more about things that we're doing, go to our Advanced Air Mobility website. That's nasa.gov by accessing nasa.gov. The working groups information is all on that portal. Then the playbook series is available there, and many other things that we're doing on STEM. We have a STEM toolkit, which is also interesting. And then a lot of public events are also announced at the Twitter as well. But really, as I mentioned, I'm really excited about advanced air mobility at large. My personal research has been on the airspace management, but in general, for the entire mission, we look at aircraft airspace as well as community integration considerations. And I personally really believe that if we are successful at this, which we will be in advanced air mobility, it could totally transform the way we live and work and where we do that and how the cities and towns and countries will be basically set up in the future, in the long future. It may not happen right away, but it really has that transformative power because you are no longer confined by the types of transportation system that happens today. I mean, if you look at history of civilization, people used to live around rivers because it gave them access to transportation. This really advanced air mobility unleashes that. You no longer have to be basically uh, constrained by the infrastructure of that transportation. You can go anywhere you want through the air. So this is really very exciting. And thank you all for participating in this journey together. Best of luck to those who are participating in that challenge. I think it's going to be fascinating. Would love to see how things pan out. And we appreciate you being part of generating and creating a history for future. Thank you for your time, and I'm happy to answer any questions.
Thank you, PK. If we have questions, please utilize the Q&A function in the Zoom webinar. PK, I wonder if you could go back to the resources that you had mentioned just previously in the slide. Really helpful is As PK had mentioned, these resources are particularly useful, and we encourage you to utilize them, to check them out, and we will certainly make them available to you as well. As a reminder, the lecture is being recorded, and it will be posted to herox.com/GoAERO for anyone that would like to review it afterwards or would like to share it with your team members as well. And we encourage you to utilize the information that PK has provided. I wonder, PK, if you can speak to a little bit more about your thoughts on the GoAERO Prize and where you sort of see it fitting into all of the work that NASA is up to, and how you see sort of the benefits that the outcomes of the prize can be useful to, to what you've been working on, particularly in the wildfire space and in other areas as well.
Yeah, no, I'm really excited about the GoAERO Prize. I was also involved in the first one, Go Fly Prize, a few years ago. And I think this is really one of the ways we can spur innovation in this space. I think we really have a great opportunity given that the technology is evolved in terms of communication and computing and such, that I think we can push boundaries and integrate all those pieces to make aircraft that are more autonomous and be able to service and basically communities that need this. So I'm really excited about this, and the things that we would love to learn from Go Aero Prize is what kind of systems work, and particularly in case of autonomy, how we are going to do detect and avoid, how we are going to basically um, fly with or without GPS, what happens when something fails, what your failure criteria is, how do you maintain safety. So there are lots of interesting things you're going to have to think about, communications and such, navigation, surveillance, ability to operate under cold weather and things like that. So, these things would be really valuable for us. I think it would be really good to collect data from a lot of these experiments that are going on, not even at the final stage, but along the way as to what people are learning. I would love to sort of create a book of learning from all the different teams as they go along so that we all can share that and accelerate the transformation towards autonomous operations. I think I'd love to see some kind of a book of learning that we publish and put together from various teams and what their learnings would be.
Yeah, absolutely. I think that the teams would be particularly interested in that as well because of the cross-section and the ability to then collaborate as well on what each of the teams are learning. One of the questions we have is, what challenges are you expecting for certification by FAA of firefighting eVTOL UAV systems?
Yeah, certainly. In terms of challenges, it's always making sure that the safety. So, of course, certification has a number of things involved. One is airworthiness aspect, and in terms of autonomy, we have a list of challenges that we have identified. In terms of what happens when, how do you operate when there is no communication available there? What do you do if the GPS is degraded? Um, what happens when the terrain is completely new? How do you actually avoid the terrain collision and collision with other aircraft, so detect and avoid not just with other aircraft and other things in the airspace, but also with any ground obstacles. So lots of interesting things that are being done, and those are the pieces that we are working on towards figuring out what the requirements are. Obviously, you will see some aircraft that have either optionally piloted or uh, s- you know increasingly autonomous features. So a number of companies are already in that space. So we are also collaborating with them to understand how they are building those things. And main thing is to test them and set requirements. I think fundamentally the goal is to identify what the functions are needed and what the requirements are needed to safely enable those operations. Weather is another area, right? What kind of wind they can tolerate, particularly wildfire, as you saw in Pasadena area and Los Angeles, the lot of wind. So obviously, you may not be able to operate in 80, 100 knot winds, but what are the tolerable winds that these aircraft should operate. That's another area that we want to understand.
Okay, great. Thank you. I wonder, PK, if you can speak to maybe just a little bit of advice that you might offer to the GoAERO teams as now they're moving into stage 2. They're working on building their actual prototypes of their devices. Given
Yeah.
the breadth of expertise that you have in AAM, what are sort of the top key nuggets of advice that you might provide to them as they're working on building now and actually sort of figuring out what they can take from paper to actual prototype?
Yeah, that's a great question. I think, and one, a couple of areas where I think I can offer my perspective, and different people may have different perspectives. But one is, I think, if you can start right from the beginning, some kind of digital replica of your model, your subscale, all the way to the final scale, and then evolve the digital aspects. I think it will go a long ways. It might take a little bit more time in the and add a little bit of overhead in the beginning, but in the end, I think all the learnings will be captured better, and you will have a much better way to repeat that or improve on it. It will also cascade beyond just a few people, because I think it can be shared much more easily. So if you can create a digital twin and use the what we call model based system engineering kind of tools, that would be a useful exercise. And I think that maybe at the end it could be shared with many of the companies, or if you want to launch your own company afterwards, that's also really fascinating way to basically capture all those learnings. So that would be one area where I would think that you may want to think about. Second is, focus on like critical things that you want to be really good at, whether it's detect and avoid, or some kind of communication, or ability to operate without GPS. You may obviously, you're all going to be really great engineers and design this in a way that will be sophisticated and integrated to be able to operate together various pieces. But I think focus on some core piece that you genuinely want to transform in a different way. So, as I mentioned, GPS, degraded environment, or types of communication you all detect and avoid. How do you do that? Or efficiency of the aircraft, or noise, or however you want it to be. But you know figure out what your core, that you're going to transform, and focus on much of your energy onto that, and the rest of the stuff you build it. But you don't have to improve everything, but try to improve one thing to a very great depth. So that would be one area that I would say you can.
And that's really, really helpful there, PK. I think I would just sort of echo as well that it's important that teams understand, obviously, that we have 3 missions ultimately at the final fly off. And remember that you may discover that you may excel in one of those missions, and that's completely okay for the purpose of the competition. You may just want to focus on productivity or maneuverability based on what you've constructed, and you may excel very much in that particular area as well. So that is an option also to keep in mind. So just make sure that you understand the rules really thoroughly as you are developing your aircraft. PK, what are your thoughts about certifying artificial intelligence software for AAM applications?
Yeah, that's a very good question. I think we are still in the research stage to figure out how to certify those things. Now, there are various degrees of artificial intelligence. You can use it off-board artificial intelligence and check the learnings through reinforcement learning scale systems, and then integrate them once you are comfortable with that. That's one approach. But on the fly learning and integrating that right away into the operations is a challenging thing for safety critical systems like aviation. So my thought is that I think um, the learning that happens through artificial intelligence, can be captured through digital twin, then figure out whether that learning is valid and will not compromise or sacrifice anything else or impact safety, and then only you basically ingest that learning into operational system. So that would be one way to do that, and that's kind of by and large what we have been working with some of the collaborative projects with the FAA and such That's the approach we're taken. Learn, review the learning, understand what that is, and do some reinforcement about it. Humans can also do that, and then only you install that new learning.
Is NASA interested in new advanced electric propulsion technologies? And if so, which programs would this apply to, and which NASA locations would be best to engage with in the 4 that you highlighted?
Yeah, a good question. So, yes, we are definitely interested in electric propulsion technologies. Traditionally, NASA Glenn is the center where the propulsion research goes on. So that would be where I would start. But any other site, most Langley also has some key aspects of propulsion. Ames has some, and Armstrong will be the flight testing. But you can go anywhere you want. But I think Glenn is really the place where you could focus as a starting point. And yeah, absolutely interested in propulsion. In fact, there is a project that I didn't talk about, a program called Advanced uh, AAVP. So, Advanced Air Vehicles Program, AAVP, Advanced Air Vehicles Program. That program um, has some work on electric propulsion, and they are looking at megawatt size, sort of propulsion systems. And there is an electric propulsion demonstrator also NASA is working on. So you may, if you do search on that, you'll find some aspects of that, and that would be where I would highlight and contact folks. And
Is there anything regarding NASA's advanced air mobility within NASA's technology transfer office that might help with GoAERO?
let's see. I think so. I think the two aspects that I mentioned already, that we have made it public, so that I'll go back to that. There is a one. Let's see. So this Raven aspect, I think, and then the reference aircraft, we have some of these design tools are available. You can also go to these websites and and get some learnings from what we have already done. And then there's another one that's AirView, the airborne instrumentation for real world video. So there's a lot of data set that you can use to test out, for vision data set. And that may be something that you can use. There's also some tools that if you go to RVLT, which is this particular project, I'll go back to the project names so that you have that. Revolutionary Vertical Lift Technologies, RVLT project. If you go to their website, there are some design tools that are available that NASA has built for decades now, and people have been using it. eVTOL companies are using it. I would highly recommend you do that. You go check it out. There's also books written by NASA scientists. That you can. Wayne Johnson is one of the famous ones. He's got a book on that. But RVLT has a number of tools that they have built for design of the aircraft that you can tap into.
PK, does NASA offer internships for international students?
I believe they do. If you go to, I'm just not familiar with the process for that, but they do offer those. If you look into, I think there is a, if you go to the intern.nasa.gov, there's somewhere in there, there is a tab that says for international students. There's a different process for that. I'm not very familiar with it, but they do.
Great. Any last pieces, any last comments, any last pieces of tips or comments that you'd like to leave with our teams?
No, I think really I'm really excited first of all about this competition, and given that so many winners, that we have 11 plus 14 so it's really 25. So that's really exciting to see that much interest. I think I would say build a little, test a little, is the model. If you do use digital path, that would be great, as I mentioned before. But I would say continuously build and test. Build and test is a model I would use, so that you create your like plan your project in a way that you have sorted out on your basically design, and then test. How do you test it? Then you move to the next thing. So using a little bit like what scrums are used for software, but build a little, test a little is a really good way to do that. So I would test early and often, and then keep on improving on those things.
Great advice. Thank you so much, PK. We really appreciate it. As a reminder, all the teams, the expert lecture will be available on the website at herox.com/GoAERO. Be sure to look for it. Again, remember that the stage 2 registration is open, and all of the requirements for registration are available on our website, easily accessible. Please do review them. Should you have any questions, or if you'd like to schedule some time to speak with someone at GoAERO, please email us at info@goaeroprize.com, and we look forward to any comments or questions you might have.
Maybe
Um,
so I was just going to share one story with everybody.
yeah,
And it's a very inspiring story, and I learned a lot through this. So I wanted to share with you how your work is going to help transform this. So during COVID, we had a number of interns who were supposed to actually come and work in person with me, but we ended up doing remote because we couldn't bring them on site at the time. And what was happening was the farmers were throwing food because they wouldn't find anybody to harvest the food. At the same time, the food banks were on overdrive, and they were really hurting to get the food and to meet the need for people. So our interns and we worked together, and we built a website called FarmLink. And what we did is we connected the farmers with food banks to see who is interested, where the demand is, and where the supply is. And
mm-hmm.
then we worked with a company, it's a sort of a nonprofit organization called Angel Flight, which is Angel Flight West, who are basically general aviation pilots who operated smaller aircraft. And we went very close to the farmers and the farmland. We got the basically fruits and vegetables in boxes, and we basically brought them very close to again to the food banks, and then we dispatched to the food banks. So we did this, and if you actually do a Google search, you will see a media coverage on this. NASA interns and food bank. If you do some keywords, you will find it.
Mm-hmm.
So that was really exciting to see how we actually, the aviation really helped. If
Yeah.
you can just imagine if we had autonomous aircraft at the time, we would have
Mm-hmm.
done this on a continuous basis. This still required people to operate the aircraft and such. But if we had autonomous aircraft like you're building, we would have transformed that. Even now, if you have ability to actually carry fruits, vegetables, and all of that, and then continuously you can transport it. You will be able to harvest it a little bit later than when or the transportation due to
Mm-hmm.
transportation, basically time and such. So I think it changes the way everything we look at in the future. So another time we repeated the same experiment for Zuni tribe in New Mexico in the winter time, right after that summer, during COVID, and then we were able to give them 1 ton of fruits. I mean, supplies actually, water, fruits, vegetables, and food to this tribe because they didn't have access to the road at the time. So it was very interesting. I mean, that's when I really realized the true power of this autonomous aviation, how it would transform. How we can reach to people that really need this, and if we can do this in a continuous basis, it will actually change the way things
Mm-hmm.
will in many areas. So that was really really motivating for me to see how we were able to change that in aviation, how aviation really helped society.
Yeah. Yeah. Such a great story. Thank you, PK, so much. It's a testament to, the purpose of GoAERO. and why we're doing what we're doing. And I think these sort of examples really just sort of demonstrate to all of our teams just really sort of how much is possible as this technology is advancing, and how how much they can contribute by the work that they're up to in this competition and well beyond that. So thank you so much for sharing. We really appreciate it. Yeah.
Thank you.
Yeah. All right. Thanks, everybody, so much for joining us. We look forward to your participation in the next steps of the competition, and we'll be sharing more expert lectures with you coming soon. Thank you, PK, so much for your time. We really, really appreciate it.
Good luck to you all, and looking forward to the progress.
Yeah. Take care.
Bye-bye.
Bye-bye.